In this chapter we're going to be looking at properties of parallel lines mostly and their transversals. So we need to build up some vocabulary here. First of all, coplanars when we're talking about objects in the same plane. Parallel lines are lines that never cross, but they must be coplanar lines that never cross. So here we have two parallel lines. They're going to keep going and they're not going to cross. This is the symbol we use for parallel. We write this as line AB is parallel to line CD. We can also use it for segments, like segment AB is parallel to segment DC. Or I could even make a ray parallel to a segment, or a line parallel to a segment or a ray. So all of those things can be parallel. Now, if we have parallel planes, this is different than parallel lines. We're talking about two planes that never cross. We can think about this as a ceiling and a floor, or walls in the front and the back of the room. And when I have skew lines, these are two lines that lie in different planes, but they're never going to cross. They're not parallel because they're not going the same direction. All right, here we go. Two lines. If they're parallel, they're in the same plane, and they never cross, so they're going the same direction. If they're skew lines, they're in different planes, which means they're going completely different directions, but they're not crossing. Skew. Okay, now we look at these two lines, line CD and line AB. Now they're in different lanes, but they might be parallel. And that's because we could connect them in the same wall. We could think about this as a wall connecting the ceiling and the floor. That wall would still be, so if we take the line going across the intersection of the floor with the wall, and the line that's the intersection of the ceiling and the wall, we will still have it in a plane there. Now if we look at this box here, it's supposed to be a three-dimensional figure, but it's represented on a two-dimensional plane. So we have to interpret what everything is. We've got a bottom and a top, a left and a right, and a front and a back. And so if we want to know about the planes that are parallel to plane ABG, then we look for, first of all, where ABG is. Notice that we're talking about the top. Now what plane would be parallel to the top? Well, that would be the bottom. So we would be looking there at plane EHC, or we could call it EHD, DHC, as long as we choose three of those points. Now for the next one, we want all the segments that intersect CH. So first, let's look where CH is, and it's right there. Now, the only points that we have intersecting right now are either at C or at H. Now from C, I'm coming out over here to E, so that would be EC. They asked for segments, so we'll name it as a segment. We've got CD coming out this way, and coming up to B. So those are all the lines coming out of C. We also have some lines that are coming out of H over here. There's only three. We've got one coming to C, but we already named that one. So now we're coming up H to G and H to E. We've kind of been marking them on our picture as we go, so we know that we've got all of them. Okay, name all the segments that are skewed to BG. So for this one, we're going to go find where BG is. Okay, and that's our top segment over here. So if we're looking for skew, we first want to ignore anything that's parallel. So like FA, ED, and HC, those are all parallel. They're going the same direction. We'd also ignore anything that's intersecting it, like BC or BA or GF or GH. Those are all intersecting. We want lines that are not going to cross it and are going a different direction. For example, CD, it's completely on the bottom. It's never going to go up to the top where GB is. So any of these on the bottom could be skew. We also have CE here. So first we've got CD as a segment, EH, and also going this way we have CE. Now all the segments that are parallel to EF, go ahead and take a moment, pause it, and figure that out. Okay, and then the answer is AD, BC, and GA. Okay, the next word is a transversal. Now, transversal is a line that intersects two or more lines. Now, this line J and K, they do not have to be parallel. A lot of people think that transversal is talking about when we have parallel lines. Now we usually use transversals with parallel lines, but the lines do not have to be parallel. It is any line, this red line, that crosses two other lines. So we say line L is a transversal of lines J and K. So even if they're all crossing like this, I can say line L is crossing J and K, so it is a transversal of lines J and K. Okay, if I look at line J is crossing L and K, so line J is a transversal of lines L and K. Looking at K crosses both of those lines, and so K is a transversal of both L and J. Now there are also special names for angles formed by a transversal, so we can look at special pairs. Now first we can look at interior angles, so these are the ones on the inside, interior, and we also have exterior angles, which would be the angles on the outside. But mostly we want to look at special pairs. Now the special pairs are the alternate interior angles, so we're looking on the inside. So for example, 3 and 6 are on the inside. They're a pair. They are on alternate sides of the transversal, and they're on the interior of the parallel lines. For the same reason, we could have 5 and 4. They're on the inside, the interior of our parallel lines, and they're on alternate sides. Now notice the basic picture of this between these two angles is like either an S or a Z shape when we have alternate interior angles. Okay, moving over to the alternate exterior angles. We're looking on the outside, and we're going to alternate to the other side. So 1 and 8 would be an alternate interior angle pair, and 7 and 2 would be an alternate exterior angle pair. Now for this one, it's not as clear a picture, but we would definitely be going on the outside in opposite directions like that. The next pair is the consecutive interior angles. Now consecutive interior angles are going to be on the same side of here, so like 4 and 6. Notice that it makes sort of a C shape with our angles. Same thing with angles 3 and 5, that we get sort of a C shape going the other direction. Those are our consecutive interior angles. We can also have corresponding angles. Corresponding angles are in the same position. So if I think at any line, if I think top right, top left, and bottom right, and I compare this from either part, I can notice that 1 and 5 are both on the top left, so they are corresponding angles. They correspond to the same position. Angles 2 and 6. They also correspond to the same position. Here they're the top right angles. We can look at 3 and 7. They're both on the bottom left. And that leaves us with 4 and 8, which are both in the bottom right.